Hello, welcome back. So what we want to look at today is be able to find the domain of a function. And so our goal is to do just that, first to find the domain of a function. And also, once we found the domain, also be to write the domain function in interval notation. So remember the domain of a function as, let's read this part. The domain of a function is a set of all values that we can use as inputs. When the domain is given as an equation, then unless specified, the domain can contain any values that do not make the output imaginary. Or imaginary means you have a negative number under an even root, like a square root or a fourth root, or undefined means you're dividing by zero. So as long as your domain can include any numbers that don't cause either one of those things to happen. So then we need to find the values that result in output. We need to find any numbers that would cause our function to be either imaginary or undefined. So to do this, approach it for both cases. So I want to exclude from our domain any numbers will make the denominator zero. So if the denominator contains a variable, and set the denominator equal to zero and solve to see what number will make that denominator zero. Or it could be more than one number. It might not be just one. Now, we also want to exclude any numbers that will make an output imaginary. So if there's a variable under an even root, once again, like in a second root or fourth root, we're going to take the expression under that root and set it greater than or equal to zero and solve to see what numbers will make the output real. In other words, those from this, we set that expression greater than or equal to zero and solve. That then will tell us the domain by telling us what numbers will be okay to use, what numbers will make it real. Any other numbers will make it imaginary. This will be an interval of numbers as opposed just to one or two numbers. Also, an odd root does not produce imaginary numbers. So if we have an odd root, we don't have to worry about it, at least the odd root itself, causing problems with our domain. So this last statement says the numbers not excluded will be in the domain. So if no numbers are excluded, the domain is all real numbers. So let's take a look at some examples. Our directions will just be to find the domain. Look at our first one. Let's say we call our function f. So f of x is equal to x squared minus x. So remember, we have two types of situations that can cause us problems with our domain. If any numbers make our function undefined, or if any numbers make our function imaginary. Now here, we have no denominator. There's no variables in the denominator. Okay, our denominator is just simply 1. So there's nothing will make it undefined. So I'll just say no x will make it undefined. So no x will make f of x undefined. Nothing will cause us to divide by 0. Now, the other possibility is any x will make our function imaginary. Now here, we have no even roots. So with no even roots, there's nothing to worry about from that standpoint. So no x will make f of x imaginary. So in that case, we have no problem values. So in this case, as this last statement says, there's nothing to exclude. Our domain is all real numbers. Or as an interval, we write our domain as negative infinity to infinity, meaning that any numbers, remember infinity or negative infinity are not numbers, they're more kind of like ideas. They keep going on forever in either direction. So the simplest way of writing is interval, all real numbers, okay? Negative infinity to infinity, and we use parentheses to indicate those numbers are not included because once again, infinity and negative infinity are not actual numbers. So if you have no problem values, your domain is all real numbers, unless you're less specified, unless your domain is actually restricted to some specific range or some specific domain in the problem statement. In this case, it's not. Okay. Let's look at another example. So number 2. Let's say we have this. So call this function g of x and say this g of x is equal to the square root of 2x minus 1. Okay. Now here, we don't have a problem with anything being undefined. I'm not going to write the statement here. No one thing, there are no variables in the denominator, so nothing's going to make this undefined. But since we have an even root, this could be imaginary. Okay, so g of x can be imaginary. Depending what x we pick, this would actually be imaginary. We'd end up having a negative number under square root. So once again, the way to find the domain we're going to take what's under the radical, the square root. We're going to solve this. We're going to solve 2x minus 1 is greater than or equal to 0. Because as long as what's under here is either positive or 0, it won't be imaginary. Okay. So if we solve this, it's not difficult to solve. Add 1 to both sides. You get 2x is greater than or equal to 1. Divide both sides by 2. Remember, with an inequality, if you divide or multiply both sides by a negative, you reverse your sign. But since we're going to divide by 2, that won't happen. So we have x is greater than or equal to 1/2. So as long as your x is either 1/2 or greater than 1/2, then that number will be in the domain. Anything less than 1/2 would cause this to be imaginary, or would cause a negative, result in a negative under the square root, which causes it to be imaginary. So any number less than 1/2 we can't include. This we can't. So for our domain, let's actually write out. It helps to make an interval, helps to actually write or draw this out on a number line, what we have. Once again, this is our domain. Here's 0, here's 1/2. Now, since we have the or equal to part, the line under it, that means 1/2 is included. So I put a closed circle, and then x is greater than that. So any numbers to the right of 1/2 are included. Okay. So this picture helps us write out our domain as an interval. So then our domain, let me just put it back up here. As an interval, it looks like this. So it's going to be, for an interval, right, our endpoints at 1/2. Then it keeps going all the way to positive infinity. Now, infinity, always put parentheses. But in this case, since the 1/2 is included, since we have the or equal to part, the line under here, we use a bracket to indicate that's included. So this is our domain. As long as you pick a number in this domain, in this interval, that's a valid number. It won't make this imaginary. If you pick a number outside of this, like 0, for example, if you plug in 0 for x, you'd have the square root of -1, which would be imaginary. So this tells us what our domain is. Okay, number 3. Let's say have a function we call, how do we call it, capital H of x, and this is going to be the cube root. How we do a similar one is the cube root of 2x minus 1. Now this is a cube root, and as we said, an odd root does not produce imaginary numbers. Okay, so for this case, h of x will never be imaginary because, once again, we have our denominator is just 1. There's no variable in the denominator. Nothing can make this undefined. And also, since we don't get imaginary numbers from cube roots, nothing will make this imaginary. So our domain is, once again, all real numbers. Or as an interval, negative infinity to infinity. It means every number you can plug in for x you want is valid. Okay, will be a valid number. All right, one final example. This time, let's have we make our function. It's called a capital F of x is x over x minus 1. Okay, first time we've seen one like this. Now in this case, there are no roots at all, square roots, any kind of roots. So nothing will make it imaginary. Okay, that will be a problem. But we'll say if denominator is 0, then f of x would be undefined. So the way to determine that, as we said over here, is to exclude the numbers that make it undefined. So take the denominator and solve x minus 1 equals 0 to find the numbers, or numbers, but I'll say number in this case, that will make capital F of x undefined. What number is that? Well, we take that once again and solve it. And so let's go back. We have x minus 1 is equal to 0. It's easy to solve. We have x equals 1. And this, x equals 1, will make capital F of x undefined. Okay, so what that means then, so what this tells us that x cannot equal 1. We can't use that value. Now, how to write that as our domain? Let's use a number line to help us out. So here's 0, here's 1. Now, sorry, 1. We just said that 1, we can't use that. So it's excluded. So to indicate that, it can't be equal to that. So we use an open circle. But that's the only problem value. Nothing else would cause it to be imaginary. We said nothing would cause it to be imaginary. Nothing else would cause it to be undefined. So as long as we pick a value bigger than 1, we can use that. Or a number smaller than 1, we can also use that. Okay. So we can use any number bigger than or smaller than 1, just not 1 itself. So the way I write my domain as an interval is now I have 2 intervals. Look at this one. Where does this one start and stop? Okay, it goes all the way to negative infinity, this first interval to the left. It ends at 1. Always use parentheses with infinity or negative infinity. Since 1 is not included, I use parentheses here. Now, the second interval, I have 2 intervals. It starts at 1 and it goes to positive infinity. Once again, parentheses with infinity and parentheses with 1 since it's not included. In the middle, I put a big U, which is called a union sign. So this is called a union. And it means or. Okay, so what this means, this is our domain. As long as I pick a number out of this interval or this interval, I'm good. So basically, this is, in words, this is all real numbers except 1. In intervals, that's how you'd write that, all real numbers except 1. And once again, this is my domain. As long as I pick a number out of this interval or, union means out of this interval, I'm good. So what we've learned today is basically how to find the domain of a function when your function is given as an equation like these. So once again, if you want to exclude any numbers which will make it imaginary, like we did here, or any numbers that will make it undefined, as we did in this last example. Thank you. Have a good day.